Okay, welcome everyone. So today we will be discussing magnetic field due to a straight current carrying conductor. Magnetic field due to a straight current carrying conductor. Current carrying conductor. So yesterday we have already discussed how to find magnetic field due to a small current element using Biot-Savart law. So if we have a small current element, then for that small current element, these scientists Biot and Savart, they have given the law how to find out magnetic field, and that formula is the magnetic field. I'm just writing the magnitude. It is mu naught by 4 pi I dl sine theta by r square. I dl sine theta by r square. So mu naught by 4 pi is the constant. I is the current flowing in that element. Dl is the length of the element. R is the distance between the point where you want to find the field and the current element. Theta is the angle between the current element and the R vector. So this much we know. Now we will use this to find out magnetic field due to a straight current carrying conductor. So this is a straight current carrying conductor. This is a straight current conductor. Let's say the current flowing is I. I am interested in a point P which is located here. Let's say that point P is located here and its distance from the wire is, let's say, D. I want to find field at the point P. Now this wire, it has got certain dimensions. It is not infinite long. So let's take this angle to be alpha, and let's take this angle to be beta. This angle to be beta. Okay. So I need to find out the field at the point P due to this whole wire. So what I will do, I will divide this wire into many small elements. Let's say this is one such element. Let's say its length is dl. This is its direction. So there are many small elements. You can divide this wire into many small elements. Let me take one small element here. I have taken. Let me take this as my origin. This is my origin, and this distance, let it be L. So I have taken one element, current element of length dl at a distance of L from the origin. Here, let's say this is the origin. Let's say this is the positive y-axis, and let's say here is this side is the negative y-axis. This is the coordinate system I am using. Okay, now this is a current element, and here is the point P. So this is my R. This is my R vector. So this is the direction of the R vector. This is the direction of the dl vector. So the sine theta which is talked here in this question, in the Biot-Savart law, what is that theta? That theta is this one. That theta is this one. The theta which is talked about in Biot-Savart law is this one. That is the angle between this dl vector and this r vector. So now using this formula Biot-Savart law, I can write down field due to this dl element, and then I can integrate that to find out field due to all the elements. That means to find out field due to the whole wire. So now let me continue. So this is field due to one element. Now let's say B is field due to the complete wire. B is field due to the complete wire. Complete wire. So here I am using the term dB to mean field due to one element and B to mean field due to the whole wire. So what is B? We know this logic. It is just integration of dB. Integration of dB, or integration of mu naught by 4 pi into I dl sine theta by r square. Now here you see there are so many vectors in this integration. So many variables in this integration. So it cannot be solved. So we need to change everything into one variable. Here you see which are the constants and which are the variables. As I am changing this dl, so dl can be here, dl can be here, dl can be here, dl can be here. So dl can be anywhere, na? So now as you choose different dl, will mu naught by 4 pi change? No. Mu naught by 4 pi won't change. So this is a constant. Will I change? No. So I is also a constant. Will DL change? Yes, DL is changing. Will theta change? Yes, theta will change. So that is a variable. So this DL, this theta, they are variable. Achha, will this R change? Yes, this R will also change. So R is also a variable. Theta is also a variable. So here what you saw, DL sin theta R square. These are the variables. Mu naught by 4 pi and I, they are the constants. So take the constants out. So this becomes mu naught I by 4 pi and then integration of DL sin theta by R square. So those quantities which were constants, I have taken them out of the integration, and those quantities which are variables, now they are inside the integration. But still the problem is there are three variables. One is L, one is theta, and one is R. So we need to change everything into one variable. So how do we do that? So let's look at this triangle. Look at this triangle. This triangle where this angle is there, this phi angle is there. Look at that triangle. You will find it like this. So this angle is phi. See, this is R, this is L, this is D. I think you could notice that triangle. Huh? With my laser light, I am showing here. That triangle is here. You see this? That triangle is here, which I have drawn here. Okay, now come to this triangle. Using this triangle, we will convert all the variables into one variable. Acha. So let me do that. Okay, so from this triangle, where is theta? That theta is somewhere here. That theta is somewhere here. Acha. So I will change everything into phi here, so that it becomes easy for me. That phi is changing from alpha to beta. So let me change everything into phi. So phi is also a variable which is changing as DL changes. So I am changing L, theta, R. Here all the variables L, theta, R, everything into the variable phi. Okay, how will I do that? Okay, first of all, look at this point. So what we see, theta will be let this be, okay, let's name it x. Theta will be 180 minus x. 180 minus x. Now that x will be how much? That will be 90 minus 5. Okay, so this comes out to be how much? This comes out to be 90 plus 5. This is degree. 90 degree plus 5. Okay, so theta got changed into 5. So here theta is there. I can put there 90 plus 5. Okay, now what about R? Okay, look at the triangle. So from the triangle we can see D is a constant. So let's change everything into D and phi. So I know, or we know, what we know. We know so many things, but here we require R cos phi. R cos phi equal to D. Achha, we are interested in finding R. So R equal to D sec phi. Bring that cos phi this side, so that becomes D sec phi. So this we require. This R we require. This theta we require. Okay, so we have found R, we have found theta, everything in terms of phi we are finding. Okay, now still I need a DL. Okay, again look at the triangle. Again look at the triangle. So we know, what do we know? Tan phi. Tan phi equal to L by D. Okay, so L equal to D tan phi. Now be careful. The D which I am using here, this is not the D of differentiation. This is the D of distance, this one. But the DL which I have used here, that D is not distance D. That DL is, the differentiation wala D applied to L, small element DL. L ka small element, like that. So let me now differentiate here. So this side it becomes DL equal to this side it becomes D sec square phi D phi. Now be careful about all these different D's. This DL, this is the D of differentiation. This D phi, this is the D of differentiation. This D is the distance here. If you get confused, then better you can use some other symbol instead of D. You can't use R also, because R is also used. Maybe you could have used X. Anyway, so be careful here. Now let me put all these values of DL, of theta, and of R here. So then this equation becomes, this you can name also, equation 1, equation 2, equation 3. So find out the values from all these equation 1, 2, 3 and put it there. So this comes out to be mu naught I by 4 pi, and integration dl becomes how much? Dl becomes d sec square phi d phi, and sin theta becomes how much? Sin theta becomes sin 90 plus phi. Okay, and r becomes how much? R becomes d sec phi. So this becomes d square sec square phi. Okay. Okay. So now this much will be equal to. Okay. So things have become little clumsy. So I will erase some things here. Okay. Now these things are not required. So whichever things are not required, let me erase all these things. Equation 1. From equation 1, we had found the value of theta. From equation 2, we had found the value of किसका वैल्यू था r. From equation 3 we have found the value of dl. Okay, so I have erased everything. Now let's continue. Here you see everything got converted into one variable only. This is mu naught I by 4 pi, and you see sec square phi it gets cancelled out, and 1d also gets cancelled out. 1d remains, take that out. Now inside integration you have only sin 90 plus phi, that is cos phi, and this d phi. So now what are the limits of d phi? Here phi is changing from, phi is one extreme value can be alpha, but alpha downside, so we can't write it as plus alpha, because if we write it as plus alpha, then there can be another angle alpha on above side, on the top side. What you will write that angle? Now both you can't write as plus alpha because they are two different things. So this we will term as minus alpha, and the other extreme values of phi can be beta on the upper side. So let's write that as plus beta. Okay, so now integration of cos phi is how much? It is sin phi, है ना? Sin phi का differentiation cos phi, तो cos phi का integration sin phi, so it is from minus alpha to beta. So you put the limits, so finally it comes out to be, I'm writing it here, the final answer, mu naught I by 4 pi d sin alpha plus sin beta. So this is the magnetic field due to a straight current carrying conductor. Okay, so we have found out the magnitude. Let's go to the direction. So let's go to the next slide. Okay, create a slide. So here is the new slide. Okay. So we have found out the magnitude of the field is mu naught I by 4 pi d sin alpha plus sin beta. Now how to find out the direction of the field? So right hand thumb rule. What is right hand thumb rule? So right hand thumb rule means, here it means hold the wire in such a way, hold the wire with your right hand, of course. So this is right hand thumb rule, so of course you have to hold it with right hand, simple. To hold the wire in your right hand in such a way that the thumb points in the direction of current, points in the direction of current, then curling of your fingers, give direction of magnetic field lines, give field lines. field lines. Okay, so yesterday also I was talking about this rule, right hand thumb rule. So let's see. So here the current is flowing in the upward direction. So put your thumb in the upward direction and try to hold this wire. So you will find your fingers are curling in such a way that here you see your fingers are entering into the paper. Here the fingers this side they are coming out. Now my point P is this side. So in all these points, this side your fingers are entering, this side your fingers are coming out. You can understand that as if there is a circle entering here where I am written cross, it's coming out of the board where I have written dot, and this wire is edge of the axis. So this is imagination. You imagine, try to imagine. So here if I ask what is the magnetic field, the direction of magnetic field point P, so your answer is into the board. If I have a point P dash, let's say this side, and I ask you what is the direction, so your answer will be out of the board, right? Let's for that matter take another example. Let's say now this is the wire, this is the wire, and the current is going downwards. Into means the current is going downwards. Okay, now where will be the field lines? So again, try to, so imagine here is a wire, that wire is vertical, that wire is vertical to this plane. Therefore, I have drawn it as cross. Cross means the current is now entering inside. So hold this wire in your right hand so that your thumb points in the direction of current. That means your thumb is in downward direction. So take your right hand and try to hold the wire. Thumb in downward direction. So what you find? Now you find your fingers will be curling in this direction, isn't it? Your fingers will be curling in this direction. So these are the magnetic field lines present around the wire. So if I ask you at this point P, where is the field? What is the direction of the field? So your answer will be at this point here. At this point, so the field lines are like this. So you take the tangent. So at this point, the field line will be towards left. At this point, this is the tangent. So the field line will be, the magnetic field at that point will be upward. At this point, the field will be in this direction. At this point, the field will be here. At this point, the field will be here. So just draw the tangent. Wherever you want to find the direction of magnetic field, draw a tangent there. That gives you the direction of the magnetic field. Okay, at this point, draw a tangent. So magnetic field is in this direction. So at this point, now the question may come, why I am just drawing like this? I could have drawn like this also. Na? Why like this only? Why this only? Why not this? Simple. See, look at the direction of the current. It is in this direction. So this one, not this one. Okay. So answer will be this one. You have to draw tangent in this direction, along the direction in which the arrow is there. Okay. This is how you can find out magnetic field at any point. Let's say here is another wire. Now the wire is again vertical, but now the current is coming out of the board. So now the current is coming out of the board. So therefore I have denoted it by a dot. Now again, if you want to find out the field lines, so try to hold this wire with your right hand so that your thumb points in the direction of the current. That means your thumb points in upward direction. Okay. So upward direction. So how your fingers get curled? Of your right hand, not left hand. So this is a common mistake. You know, people forget which is right hand and which is left hand. So you have to hold it with your right hand. So this time your fingers will get curled like this. This is how your fingers get curled. So this is the direction of these are the magnetic field lines. Now if I ask you the direction of magnetic field at various points, so your answer will be like this. At this point, what will be the direction? Here. At this point, direction of magnetic field here. At this point, direction of magnetic field here. At this point, direction of magnetic field here. Like that. Okay, so you understood. This is a very easy thing. So we won't go deep into it. So we are done with it. So this is how we find out the direction of magnetic field using right hand thumb rule. Right hand thumb rule. Okay. So now we have found out the magnitude of magnetic field and the direction of magnetic field due to a straight wire. Now let's use this to solve some questions. Okay. So find out field. Field means magnetic field due to an infinite long current carrying wire. An infinite long current carrying wire. Current carrying wire. Okay. So that means I have a wire. How long is it? Infinite long. That means this side also the wire is up to infinity. This side also the wire is up to infinity. Now let's see, here is my point P. This is at a distance D. I want to find field at this point. So we know the formula. It is mu naught I by 4 pi D and sine alpha plus sine beta. So let's substitute the value of alpha and beta. Try to find out how much is the alpha. So here, if you try to draw, alpha, this, try to join the end of the wire with point P. So it will become almost a parallel line, right? So here you see alpha, it becomes 90. Similarly, try to join point P with the other end of the wire. So that also will become 90 degrees, you see. So here your beta is also 90. So substitute them. It comes out to be mu naught I by 4 pi D, and this becomes sine 90 plus sine 90. So sine 90 plus sine 90. So sine 90 is 1. So this becomes 1 plus 1, 2. So that becomes mu naught I by 2 pi D. Remember this as a formula. So field due to infinite long current carrying wire means it is mu naught I by 2 pi D. Remember it. Mu naught I by 2 pi D. So what is the direction? Here I have taken a point P. Here I have taken a point P. Here the current is flowing, let's say here. So here it will be into the board. If I ask you about a point here, there's a P dash. Here the magnetic field will be out of the board. Use right hand thumb rule, you will get the answer. Okay. So remember this as a formula. Magnetic field due to an infinite long current carrying wire equal to mu naught I by 2 pi D. Acha. What if this wire is not infinite long? What if this is a semi-infinite wire? So let's solve another question. So the wire is semi-infinite long. Now try to find out the magnetic field due to it. Okay, I am writing the question here. So this is semi-infinite. Semi-infinite means, here it has got a starting point, but then it doesn't have a ending point. Here it is up to infinity. Now the point is here. At a distance of D, the point is here P. Okay, now what you see here, here we know the formula for magnetic field. What is that? It's B equal to mu naught I by 4 pi D sine alpha plus sine beta. Sine alpha plus sine beta. So we take that alpha and beta from this line. Now you see alpha is 0 here. You see here alpha is 0. Achha, but you see beta, you try to join the other end, with the point B. So you will find this will come out to be 90, because here for the sake of showing you I am drawing it here, but actually the end is not here. It is even out of my laptop and out of this room. So it is 90. So here beta is 90. So substitute these values here in this equation. So what you get? You get mu naught I by 4 pi D and then sine 90 plus sine 0. Sine 0 plus sine 90. So sine 0 0, sine 91. So this becomes mu naught I by 4 pi D. Mu naught I by 4 pi D. So what is the answer? It is mu naught I by 4 pi D. So there it was 2 pi D. Here it is 4 pi D. Simple. Achha, what will be the direction? Direction, use right hand thumb rule. So here at point P, right hand thumb rule. Achha. So here at point P, let's say the current is flowing here in this direction. So at point P, you will find it will come into the board. If the point would have been somewhere here, this side, P dash, let's say P double dash. At these points, the magnetic field will be out of the board. Am I clear? So this is how you find out field due to semi-infinite wire. Field due to semi-infinite long wire. Infinite long wire. Okay. So in these questions, mathematics was not too much involved. The angles were very simple, but every question need not be like this. So sometimes angle may not be mentioned also. So from geometry, you need to find out, what is D, what are the angles, and then you need to solve them. So you remember this formula. Remember this formula. Now let's do some other questions where the angle and distance need not be directly given, but then you need to get it from the geometry and then solve it. So let's solve such a question. Let's solve such a question. Here is a square loop of side A. Here is a square loop of side A. Okay, let's say the current is flowing like this. In which direction is this? Anti-clockwise direction. Okay. Let's say the current is I. I want to find magnetic field at the center of the loop. So here is the center. Question. Find magnitude and direction of the magnetic field at the center. At the center of the loop. Find out. Okay, now match your answer with me. Check if you've done it rightly. Okay, now, so we know that this loop is made up of 4 straight wires. So let me find out field due to one wire, and then I will multiply it. Let me see if I have to multiply or I have to subtract. That depends on the direction. Let's say the direction of every magnetic field produced by every wire is in the same direction. Then I can just multiply it with 4. Okay, so now look at this first wire, second wire. Each side is a wire, straight wire. Each side is a straight wire. Okay, so now look at this, first wire. So this is D, if you can notice. This is the D. The point is at a distance D from the wire. And you see, these are the angles, alpha and beta. These are the angles, alpha and beta, if you can notice. Acha. And you see the magnetic field, use your right hand thumb rule, you will find the magnetic field due to this is out of the board. Is out of the board at that point. Now similarly, you see for wire 2 also the magnetic field is out of the board. For 3 also it is out of the board. For 4 also at that point it is out of the board. So I know that their magnetic fields, they are produced in the same direction. So I will just do, simple addition. So what is the total field? So total field, I can write field due to 1 plus field due to the second wire plus field due to the third wire plus field due to the fourth wire. Sabka, which direction? Out of the board. Out of the board. Now because of symmetry, you see all the wires, they are of same length and they are situated at the same point from the center also. So B1, B2, B3, B4 magnitude wise all of them are same only. So let me just do it 4 times B1. So what is B1? Put it from there. So we know it is mu naught by 4 pi. The formula, let me just write down the formula. Mu naught by 4 pi I by D and then sine alpha plus sine beta. Okay, what are the values of alpha and beta? Who knows? For a square, what are the values of alpha and beta? You will have 45, 45. And alpha and beta will be 45 each. Acha, what is the value of that D? That D will be A by 2. Now you see these things were directly not given, but from geometry you can find out. From geometry you can find out this information. So after you have found out, you know the formula, put them in the formula. So this is how much? Mu naught I by pi D. Achha, D. So 4 I am cancelling, and then D, instead of D I am putting A by 2, and then sine alpha. So let me put it sine 45 degree plus sine 45 degree. Acha, how much is this? So this comes out to be 2 mu naught I by pi a, and then sine 40 by 1 by root 2 plus 1 by root 2, that is 2 by root 2. So that is root 2. So this is 2 root 2 mu naught I by pi a, and out of the board. Done. So this is how we find out magnetic field at the center of a square loop. Now, what if it is a triangular loop? Let's do another question. The next question. Here you have got an equilateral triangle. Equilateral triangle. Let's say the current flowing is like this. Let the current be I. Let each side be A. Let this be equilateral triangle. Equilateral triangle. Acha. So now you need to find out field at the center. Find field at the center. So for an equilateral triangle, center, centroid, incenter, circumcenter, everything is same only. So you find field. Both, that means both magnitude and direction you need to find out. Okay. So solve it. Solve it. All right. Now try to match your answer with me. So here I need to find out field at this point. Okay. Again, although this is a triangular loop, but I can assume that this is made up of 3 straight wires. So now what will be the total field? Total field will be, find field due to first wire, that is B1, field due to second wire B2, field due to third wire, that is B3, and then try to do vector addition. But let's check if the directions are same, then we can just do scalar addition. Okay, now using right hand thumb rule, field due to 1, so it will be into the board. Field due to 2, it will be into the board. So here you see all the wires, they are producing field into the board only at the point P. At the point P. So what I will do to field, it's B1 plus B2 plus B3 and into the board. Now using symmetry, all the 3 sides are equivalent and that point P is the center. So B1, B2, B3, they are also same only. So let me write it as 3 into B1. That's all. 3 into B1. Okay. So here B1, identify alpha, beta and D. So this is D, this is alpha, and this angle is beta. Now from geometry, how much will be D? How much will be D from geometry? Try to find out this. Geometry, क्या होगा? It will be 2/3 of the height. 2/3 or 1/3? It will be 1/3 of the height of the triangle. Acha. And because that is centroid, na? So the top part will be, top part means this much. This much. From vertex to here, this much will be 2/3 of height, right? And this much will be 1/3 of height. If you take, total height to be h. So 1/3 of height. Acha, now how much is the height here? So we know height is how much? Root 3 by 2 a. Root 3 by 2 a. That is height. Uska 1/3. So this comes out to be how much? A by 2 root 3. This is D. So now what are the angles alpha and beta? So you will find alpha will be equal to beta. Now these are equilateral triangles, so this will come out to be, this total angle will come out to be 120. So those each angle alpha and beta will be 60 degree. Okay. Now put those values here. So here 3 times B1 means mu naught I by 4 pi D. First let me write down the formula. Sine alpha plus sine beta. Okay. So this is 3 mu naught I by 4 pi D into sine 60 plus sine 60. Let me do it 2 times sine 60. Sine 60 how much? Root 3 by 2. So that becomes 3 mu naught I by 4 pi d. D is a by 2 root 3. A by 2 root 3. And then there it is sine 60 root 3 by 2. So let's calculate it. How much this comes out to be? This 2 gets cancelled out. Here 2. And it comes out to be final answer 3 root 3 root 3, that is 3 3 into 3 9. So 9 mu naught I by 2 pi a. This is the final magnetic field, total magnetic field, and direction is inwards. Okay. So today we have finished how using Biot-Savart law we can find out the magnetic field due to a straight current carrying conductor, and then using that formula we have found a magnetic field at various places where straight wires are involved, like at the center of a square loop or at the center of a triangle. Now it need not be square or need not be triangle. Wherever straight wires are involved, we can find out magnetic field. All right. Okay, let's stop here.